intuitive sense of how optimization works rather than just, explaining basic tools you can use. Don't worry though, I will be going over some tools too. This is actually part of an internal presentation I gave to our own engineers at VRChat, but I've retooled it a bit to focus on stuff creators can focus for. Results will be similar between platforms. I'll briefly touch on how things are a little different between when you're targeting Quest, but most of this will cover just about everything. Also note that this is a very large generalization. I'm sure anyone who's deeply familiar with the subject matter can point out, a dozen exceptions or more to any of these. But also, just so you know, I will be trying to ram through these pretty quick, so there will be a bit of time for Q&A at the end. And there's also a Discord channel, so if you have any questions there, bring them up. We'll try and read them out. All right, cool. Oh, that's not working. Here it goes. So just to start off, a quick background on me. You may have seen me on the occasional developer post if you're especially keen. But if you haven't, hello. I'm Feilen. I'm the performance team lead over at VRChat. I've been a pretty heavy user of the platform since 2020, but I started working here early last year after many years developing a Blender plugin for optimization. You may have heard of it, Cat's plugin, no relation. I'm also, as you may have noticed, exceptionally furry. I have been since I was at least 6 years old. Pro tip, if you're going to come up with a screen name that will stick forever, don't misspell feline. I did that. Don't good. This is actually my first foray into the games industry. Up until here, I was a more general optimization engineer working at various companies and just about every part of the stack. So first thing I want to introduce is what I like to call microseconds per animal. So frame rate is pretty hard to get a sense of intuition for how much fixing up your avatar will actually impact the overall frame rate. A lot of this is because we try to rely on FPS to explain whether or not an avatar is performant, but FPS is kind of the opposite, or rather the inverse of what you need. Instead, you should be thinking about things in terms of frame time, the actual milliseconds and microseconds you have to get in and update the game logic, play player voices, animate everyone, render the scene, just about everything. I'll be digging into what makes up the frame time in just a little bit, but this is just an illustration to give you an idea of where the impact actually lies. Oh, my other one's... So to give you an idea of how this works exactly, you basically start by dividing a second up by your target frame rate. Most of the time, this is going to be about 90 hertz on PC. That's a decent target, even if that's not the headset you're targeting. That gives us just about 11.1 milliseconds to do everything. Say half the frame time is used for a world, that's 5.5 milliseconds left for avatars. So if you got 40 avatars in the frame, you've got 130 microseconds to render each individual avatar. So here we have an example frame. I hope you all love my illustrations here. This time in a world with just 5 people. There's no problems yet. We're rendering just fine, even if your avatar is taking up half of what everyone else is combined. Note that we're covering the application itself here in the world time, networking, voices, everything else that's somewhere in that chunk. So here's a more typical scenario. You got about, say, 12 people in, and despite one person needing individually to render each and every of their teeth at about 4K, you're barely eking by. You're still making the target frame rate. Note at this time that little fluctuations in what you're looking at can put you over the budget, causing inconsistent judder. That's often worse than just a consistently low frame rate and can be quite nauseating. Sorry, this is having some trouble. There we go. Sorry, this is not, Anyway, so you get in with your friends, you hop to a party, not a big one, maybe just 20 people. And oh no, that's one too many tables. On most platforms without reprojection, this means your next frame will have to be somewhat smeared to reach the next frame target. The world starts shaking, you get that weird motion reprojection jiggling everywhere. It's just not a pleasant experience. If you're on certain types of static reprojection, that means you can get fully knocked down to 45 FPS. So you got 40, double the frame time, but now you're wasting so much of it. To give you an idea of how close this can be to reality, here's some actual captures from the OVR metrics tool. If you have a Quest, you can install it on it yourself and capture frame times. It's difficult to capture CPU frame time in a meaningful way, but this shows exact results for GPU frame time, jumping around between a few different worlds with a couple avatars of varying optimization levels. Sadly, I didn't have a super unoptimized avatar on hand, but even the little differences show up here. On PC, you can get something equivalent by installing MSI Afterburner for GPU frame times on desktop, or SteamVR for just sort of PCR frame times in general. So what's in an avatar?
Sir, these graphics are gonna kill me.
There it goes. So content optimization is actually like a professional artist skill set, which is what I've always kind of believed is a bit of a high requirement to put on end users when you just want to upload your avatar. For avatars, our eventual intent is to allow the SDK to fix pretty much everything for you at some point in the pipeline. So some representation of your avatar will always make it through. Conversely, for worlds, we pretty much only expect that kind of the original content creator will be trying to upload it, so it's a much higher barrier to entry. Unfortunately, the flexibility there means it's much harder to actually give people a ranking. So it's best to get as much background in as you can and basically check your work. There we go. So sadly, there's a lot we have to do to that other games simply can optimize away. Avatars are a big part of this, often the biggest part. They've got skinning, voices, inverse kinematics, animation, sounds, and a dozen little other edge cases to worry about. We can't even completely turn off all of these when you're off screen or distant either, because sounds and like other goodies are controlled by the animation controller at the moment. So we have to process animation states even when you can't see them. My team has spent the last roughly year or so chiseling away at like every little bit that you hopefully won't notice, and improving what you otherwise would. But a nice thing to note, which will hopefully get better as VRChat, as we move VRChat to new rendering technologies, is that a bit of work gets to execute in parallel between the CPU and GPU. This is really good news for us, but it makes it a little extra difficult to really profile how much time the CPU is taking, as the platform can only really give you an estimate at best. Although CPU is frequently one of the most overburdened resources in VRChat, the major FPS drop you see between desktop and VR is almost entirely up to the GPU. If you're really trying to narrow it down though, one way you can get an estimate is to invert your frame rate and then subtract GPU frame time. That'll give you an idea of what CPU time can't run in parallel. Our team has been developing a tool for a little while we call the Quelf, or Quest Array internally, which is broadly a bunch of quests on IKEA shelf that we have rigged up to navigate to a bunch of worlds and spit out graphs. Just to give you an idea of how hard it is to gather, meaningful stats on this. But different avatar components can have different impacts, and really giving an exact sense of the impact is hard, as you saw. Unfortunately, this only really gives us an idea of how much impact you'll have with your avatar. If you're designing a world, it's better to try and have an intuition and just test often, test constantly. In the meantime, just stick with the avatar caps. They don't capture everything, but they will give you a decent idea. So at the highest possible level, if you're doing avatar work, you're probably all familiar with the avatar performance ranking system. As I'm sure many of you are aware, the avatar performance ranking system is a bit of a kind of one-size-fits-all approach to maintaining a basic performance level for avatars. It has a fair number of false negatives for bad performance, but not nearly as many false positives. That is, we expect if you've been flagged as very poor, your avatar is probably actually having a much heavier weight than most avatars. If you've been flagged as excellent, you might have some issues, but generally we expect you'll be excellent. Another shortcoming of the performance ranking system is that it tries to break things down into rough categories, but it doesn't really have any enforcement beyond a few hard clamps. To make this a bit easier to make sense of, I'll only break down the couple optimization levels where you're likely to see the most difference. Poor or better on PC, and medium or better on Quest. After that, you're super likely to be perf blocked by most people. That said, please aim for better if you can. The limits we're discussing here are bare minimum, and if you're more than likely than still stealing a little few people slots from other people around you at this rate. More on how to think about that in the next section, but I'll also be trying to give you the simplest possible steps you can take to fix this, including what tools will pretty much fix it for you off the bat, and what happens if you don't, as well as any plans we have, internally to fix it for you. For all of these, if you can, I highly recommend targeting Quest with your limits, except for like triangles and materials. Having your avatar have feature parity between clients will get you a massive amount of appreciation from mobile and Quest users. Triangles are sort of unintuitively expensive. People frequently kind of point to fill rates on modern GPUs, but the worst cost for us is actually still what comes down to skinning them. That contributes a big chunk of our frame time for both PC and Quest. That said, we're slowly getting the most egregious problem solved. For example, when we moved to Unity 2022, there was a every frame copy that doubled the cost of having shape keys enabled anywhere on your avatar. So what happens if you don't optimize? You're blocked. What do you do about it? If you can bring it back into Blender and use decimation or use Mark Creators tools, which are non-free, it will deal with it for you. On our side, we've been experimenting with some SDK side decimation and atlasing. It's slow going, but we hoping to have something by the end of the year that will help you with this. Oh, my thing got one ahead. Texture memory is another one that will block you. It used to be that loading too many avatars would simply kick you out or crash, but now we try to limit it. Soon though, we'll be trying to introduce MIP streaming. That should leave it pretty much just a download size problem. So if you don't optimize this, again, you're gonna be blocked. What to do about it? Super easy, just reduce your texture size, quality, or type until you're under the cap. Thry's avatar tools can help you here too. It'll suggest texture format changes that can save you huge amounts of memory at like no other cost. Also, look into packing textures. If you're using separate metallic and ambient occlusion maps, you can usually just stick those together. They use different color channels entirely. Our SDK now tells you to do this if you're using standard light through the UI. Important to note here, crunch compression does not help with the actual size once it hits your graphics card. This will only save you download time, and it's been associated with hitching in some use cases. Use it sparingly. MIP streaming is coming very soon. Make sure your textures are MIP mapped. They'll look better that way anyway, but some huge improvements are coming to mesh memory. One thing to keep in mind here is that even when you're checking how big your textures need to be to see the full detail, you can generally set your Unity viewport to something like 50 to 75% resolution from a few meters away, and that'll accurately represent what other people will see of you in VR. And then one big extra freebie, I always suggest turning this on, but turn on Kaiser MipMap filtering for textures. The default in Unity is box, but that really blurs textures from a distance as the lower MIPs load in. It's basically free detail. There's no performance cost. It's just use it. What about skin meshes and basic meshes? As well as just material slots in general. They're a pretty big concern. Each one of these requires the CPU to tell the GPU to render something, which is called a draw call, which add up pretty quickly. They're a pretty significant part of GPUs or VRChat CPU costs. If you have a bunch of materials using the same shader, try to combine these. Some off-the-shelf tools can help you, can also do this for you. Again, Mark Creators tool can do this, but it's not free. And again, we hope to have something built into the SDK to deal with this for you by, hopefully the end of the year. Bones. Bones aren't actually that common of a case for getting rejected, as usually you end up with what the avatar creator aimed for and nothing else. Sadly, they're another blocking feature. They're really difficult to optimize for. If you have too many bones, you will get blocked over the levels. If you have bones that are completely uninvolved in the avatar animation, they're non-skinned, you can manually delete them from within the hierarchy in Unity to get some back, but really the best recourse of action is to bring it back into your 3D modeler. There it goes. Bound size is another one that's blocking, but it's super trivial to fix. Right from Unity, you can just click edit on any bounds and edit the bounds for one of your renderers if you have, for some reason, a render that's like 10-25 meters for seemingly no good reason. Instant fix. Sorry, this isn't registering. Unity cloth is a bit of a weird one. Very few people use this. It actually does a vertex-wide cloth simulation, but you only get a super limited number of vertices, and they're pretty buggy. Honestly, if you haven't used Unity cloth before, it's a bad time to start. Fizzbones can give you a passable simulation of cloth, and then other people can interact with it, and it's a fraction of the cost, and it's cross-platform. Fizzbones. Truly the cornerstone of avatar interaction these days. Going over the cap will cause all your fizzbones to be stripped, so it's a really good idea to keep within a reasonable limit. Honestly, though, the limits are super generous. If you run right up against them, you can kind of add individual end bones to the exclusion parameter to slowly kind of cut down to fit inside of any limit. Other cornerstone, contacts. Highly suggest keeping your contact limits to within what works on Quest, since cross-platform interactivity is a huge benefit. But honestly, it's still pretty hard to hit the ceiling there, especially on PC. There we go. Lights. Lights are, don't use lights. Unless you're doing something for utility or testing avatar, I would generally say it's a really bad idea. One light can be used on a PC avatar without kicking you down to very poor, but honestly, you shouldn't be able to. Remember the draw call issue I talked about before? For each light in the scene, every single material in the scene in range gets an additional draw call to calculate the light's contribution, with some exceptions. This is because we use what's called a forward rendering pipeline in VRChat. Our setup is optimal for few lights, but starts to quickly get expensive for more. Basically, you multiply the cost of every single person around you. I would use emissive if you want cool effects on your avatar. Worlds try to frequently fake the effect of real-time lighting with LTCGI and other related trickery, and that has much greater impact than just a plain old light would get you. Particles. Particles are awesome and pretty easy to keep low. If you start to go over the limit here, all your particle systems are removed, but it's pretty easy to keep within bounds. Just limit the total number of particles per system until you're under the cap. Sadly, even a single particle system will cause your avatar to be marked as poor on Quest, due to some difficult to predict situations where avatars can become like explosively expensive due to overdraw. We hope to have something for that, but it's not, on the active roadmap at the moment. And then finally, audio sources. Vital to add head pet noises to your hands and presumably something else. I haven't thought of a second use case yet. We've recently added some new components which will let you swap out different audio clips without using more sources. I highly recommend taking advantage of that. As a result, we're also in the process of evaluating avatar audio on Quest, so keep an eye out there. The main resource additional audio sources take up is memory, so make sure you're keeping an eye on it. Short audio sources should be decompressed in background, longer audio clips should be streamed from disk. I believe more modern VRChat SDKs will warn you about this, but it's good to keep in mind anyway. About MISC avatar tuning. There. Not constraints. They're not currently constrained on PC. They're not allowed on Quest. This one was encouraged for a while until it turned out they're obscenely expensive in Unity for a very weird reason. We have a new constraint system that's being introduced very soon. Keep an eye out for that. No more than a handful in the meantime. Materials and shaders. Shaders are great. Abuse them as much as you can, but try to ensure that you do some GPU profiling. The overall cost of a shader can entirely be summed up by total GPU cost, and you can usually make a worst case world test by just making a giant inverted dome of it and then loading it as a world. Do that. Shader GPU cost for fragment shaders usually scales by the actual portion of the screen you're using. If you're especially clever and you don't mind spending a few extra evenings on it, dynamic shader branching can also save you a decent chunk of GPU time. Just look up how to avoid divergent pixel tiles and other kind of gotchas. It's up to taste. I'm also personally a fan of any shader that can extrapolate specularity from light probes. I'll explain that a little bit more when we get to worlds. And I personally think that just about everyone should be trying to mess with detail maps if you can. Basically, this just lets you overlay some extra color or normal maps on top of your existing ones with a totally different UV map or tile size. So you can overlay a fur texture that repeats hundreds of times, letting you see individual hairs while barely impacting render cost. To go even crazier, you can use your avatar's normal maps as an offset for other sampling and make it look like the color is being dragged around by the fur patterns. Go nuts, just profile. Grab pass shaders. Grab passes can get out of hand very quickly performance-wise, because they basically have to force another render pass step for each one. This isn't too bad when there's only one or two, but as soon as a few people have them on, it can hugely increase the render time. Most people use them for pretty insignificant details too, such as like glasses or eyes. You can get similar effects by baking in a cube map at the same location for something like 1/500th of the cost. Animation layers. The animation system in Unity actually scales surprisingly well, but if you're keen, there's some additional steps you can take to squeeze the last few % out of your avatar. VRC Fury has some extra settings to squeeze your avatar's entire animation structure down into what's called a direct write animation setup, which scales vastly better than much more complex avatar setups. The benefits here can be minimal compared to other optimizations, but if it works for you, it's a freebie. One important thing to note is that animation layers scale well within the same animator. There's basically no reason to have two animators on the same avatar, unless you're doing some kind of super unusual avatar stuff, understandably. Sorry, it doesn't want to accept my input here. Prop methods. It used to be the case that creating avatar props with varied methods all had their own drawbacks, but newer Unity versions have partially dealt with this. Popular methods include creating additional bones that hold the avatar and can be skinned out of existence by, scaling down to nothing, saving skinning costs, or using shrinking blend shapes. It used to be super expensive, but now okay. Both of these methods will work great on Quest, as long as you make sure you've combined your materials. On desktop with custom shaders, there's also UV tile discard or UDIM. That's also a great method. Blend shapes are stored pretty efficiently in GPU memory nowadays. They used to be much worse, but they also use GPU time to animate for any that's active, even if it's on all the time. VRC Fury also has a prefab that will bake your current blend shapes into your base mesh on upload and get rid of any hidden ones. I highly suggest it. It's another free upgrade. Just a quick through on worlds. I've also got some general advice here. Lighting. Lighting is pretty much what will push your world. It's worth spending a decent amount of time on it. Nearly all of the lighting in VRChat is baked in. True real-time lighting is rare. We've gradually been encouraging methods of baking lighting that take advantage of light map specularity. They use some math trickery to basically encode a light direction and spread into every pixel on a light map surface, making your worlds look real-time with almost no cost. Support for that is coming in standard light very soon. Keep an eye out. There's one significant blind spot in Unity's lighting model. All specular light is supposed to come from a mixture of specular highlights, which are from real-time lights, and reflection probes, which are baked. VRChat rarely uses real-time lights, though. There's a sort of hack you can do to make up the difference, one which I intend to include in the SDK at some point, which is called specular reflection probes. This basically just draws the reflection highlight right onto your reflection probes, so as soon as you get them with no cost. Worth a shot if you have a lot of lights without, real emissive objects near them. It can add a lot more life to your worlds, essentially. Baked culling. Baked occlusion culling is one of the biggest ways to make a much more performant, larger world, but Unity's version of it can be quite heavy on the CPU. Do make sure you test before and after trying to see if it actually helps you. If you're willing to put in the extra work, you can achieve a similar effect by using Udon to turn off known distant rooms as you enter new worlds. I think it's trying to hit my overlay. There, that worked. Poly count is still a significant cost in worlds, especially on mobile. A slightly underutilized feature in Worlds is to use LODs. We support the standard LOD group component in Unity, which drops detail as things get further away. There's a few plugins on the Unity store that can create LODs from just about any arbitrary object. I highly suggest giving those a shot. Mirrors. Mirrors are expensive. You knew that, but they're a lot more expensive than they should be, as currently Unity does not correctly cull the area outside of the visible viewport when rendering mirrors. We are working on this, but in the meantime, if you're going to use a mirror, you might as well make the most of it. Try to cover a wide area. Really tiny, detailed mirrors are a nice effect, but much more expensive than the impact that they have. World size. VR World Toolkit is a great tool for world creators, especially as it'll give you a lot of this advice as completely automated warnings. Finally, once you're to the point of trying to upload your world, highly suggest actually tuning your world's upload size. VR World Toolkit can help you do this by giving object-based breakdowns of what's biggest. And definitely, if you're going to be doing a gallery or something, it's worth trying out the VRC image downloader components instead, and just sort of loading things as players walk near it instead of keeping it in the memory the whole time. Speaking of size, stochastic tiling. Another thing that we're hoping to introduce in the coming months is a render method called stochastic texture tiling. This breaks a texture with no discernible repeating pattern down into hexagonal tiles, which are measured in random ways in every direction. The result is an infinitely repeating texture with no visible repetition. You can use a 256 by 256 texture and cover an entire parking lot, and it'll simply look real. It's best for natural textures. Things which have an obvious structure to them don't work very well. But if you combine that with the baked lighting suggested earlier, you can fit an absurd amount of detail into a world that runs on just about anything, on Quest, on mobile phones, on iOS. Now, since I have some extra time here, I'm actually going to be bringing back some stuff I covered in the original internal presentation. It helps to keep this in mind if you're designing Udon, as well as help break down frame time a little more into meaningful units. But this will mostly be focused on world creators. Data locality. Stuff is loaded in your computer in what's called cache lines, retrieved as big blocks and then kept closer to the CPU the more recently they've been used. Blocks are all loaded together, regardless of if you use the whole line or not. Retrieving stuff from memory is the real expense here. Running stuff on the CPU itself is super fast. I've scaled everything up here to human-readable terms. So in essence, if you're doing something on the CPU itself, it takes about 5 seconds inside the cache, or inside the registers, like, grabbing something on your desk. Then retrieving something from the L2 cache takes about 2 minutes, like getting up and fetching something from the rest of your house or your backyard. Getting something from actual onboard memory takes a whole 27 minutes, like getting dressed, driving to a store 10 minutes away and back. But the problem here is latency rather than speed. You can always fetch a lot of stuff while you're at the store, but you can grab a ton of sequential memory faster than you can grab a bunch of individual things. Algorithm analysis can have some blind spots around data locality. Now here's what hurts a little bit. C# stores all instances of objects in separate chunks of memory, so it can dispose of them independently. While there's likely several implementation layers deep of optimizations on top of this, for practical reasons this is still true. Exception is things declared as structs. Use that when you're using just data. So what can we do about that? Reuse of structures using pooling is a really good way to keep things actually fetched and avoid a huge overhead of garbage collection. Pooling is essentially just keeping the memory around you want to use for something and keeping track of the usage yourself. Touching a structure in any way that actually reads its contents requires fetching it. Avoid that if you're not actually going to use it in a particular frame. Algorithms are super important, but probably not going to be impacting most of you in a day-to-day way. There might be a touch of this more as we move into Udon 2, so I figure it's good to include it anyway. Come on. Most deeper algorithm analysis isn't going to affect our day-to-day work, but you never know. I'll assume you're all familiar if you need to be. But for practical concerns for everyone else, data locality is still pretty key here. Hash maps under the hood basically just turn a piece of data into an address, so you can go directly to it rather than checking everything in between. Your friend Frank lives on F Avenue, our house is down. You don't need to check every other house, basically that. Probably won't come up, but just don't use linked lists, unless you're using lock-free queues, in which case you should apply to be on my team. And then lastly, I've just got a little couple notes on here for anyone doing shader design. GPUs work a little different under the hood. The shader pipeline unpacks textures between parts of the cache, but the broad principles are the same. Important to remember here that GPUs generally aren't going to be keeping a ton of stuff between frames. So basically imagine everything is being grabbed every time anew inside the same frame. It's a bit easier to analyze, but loops and branching are bad. So generally you're limited to the most instructions happening in a single pass, which means that shaders are much easier to analyze, like statically analyze, to figure out just how many instructions they use. Mobile works a little bit differently. To keep the overall memory needs absolutely minuscule. Instead of setting up and unpacking everything in between frames, imagine it happening between every 64 by 64 tile of the screen. Mobile devices run their whole pass over every single chunk of the screen. This is why post-processing is so complicated.
Triggered by some of the technical details.
Pardon me. And just a little note here on draw calls. Sorry, I should pause for breath more often. Just a little note here on draw calls. Although they're technically a CPU thing, basically it's a draw call is telling the CPU telling the GPU to do something. It has to do at least one of these for every material in every frame. Unity has a number of ways to batch these including static batching and instancing. In a practical sense, you just need to make sure that your static stuff is batched. Instant stuff is low poly because the instance data is the vertices itself. And then finally, we should have just a little bit of time left for questions. There will also be a channel up on Discord. Feel free to ask me just about anything in there. My throat is really dry. I'm going to go fix that real quick. Ready when you are. Tupper, you want to go first?
Oh, goodness. Hello. One question I have in particular with you mentioned CPU caching, and I really appreciate the kind of human scale of that. It's a really good approach of explaining it. As many VRChatters have been discovering, like a large level 3 cache, especially on the AMD X3D CPUs, is like really beneficial not only to VRChat but lots of Unity games. Why? Like we have benchmarks, but no one really has like a great idea why.
So that's essentially what I covered. The C# keeps all of its objects in like separate allocations. So most things, if you're putting something together in C++ or C or any kind of low-level language, if you want 200 objects or something, they're in a giant row, and when you want to pull up that row, you just take the whole thing as one giant bundle. So it's basically just a box of that object. C# is like if you have a list of objects, like if you have a list of places where things are in your house and you have to go and find each individual one of them and grab them from a box. So the L3 cache lets it keep it closer to the register of the CPU, but you still have to go retrieve all of those each time.
Right.
The hope is as we move into more kind of low-level code, we've started introducing C++ and Rust into the client itself. The hope is that we will slowly start to make gains on this and, you know, solve that problem.
Gotcha. Okay, cool. Thank you.
All right. Got some questions queued up? I see we got about 13 minutes left.
Yeah, hello. Yes, I have a question here from Ellipop. If VRChat did start evaluating world performance, what would be some of the things to look at, such as ranking by real-time lights or anything else?
It's a little bit too open-ended, so we really give world creators as close to bare metal Unity as we can. So you can do just about anything with it. In general, I would avoid real-time lights at all. It would be nearly impossible to put like a static ranking on it the way we do with avatars, because avatars have a basic set of things, and you can expect that they're gonna maybe at worst use all their features at once. But worlds will be using it, toggling things in and out to make sure that performance is better. So we really can't statically analyze them. That said, we're trying to introduce as much into the SDK as we can to make it easier for world creators to create performant content. And hopefully eventually be able to give some easy ways to test it rather than having to run your own profiling.
Alrighty. All right. Next question here from Snowderg. Mentions that one of the main reasons that avatars go very poor is having to add everything to your avatar when it could be a separate asset. The question is, does VRChat have any plans for an avatar props or equipment system in the future, or what would be some ways to mitigate that?
I don't think we have any concrete plans for props. Obviously, we've been toying with it, but like, you know, we need to make sure we have it right before we kind of roll it out to people. As for creating your own props, atlasing will help. We hope to have some way to have like individual toggles with like the auto atlasing that we're hoping to introduce to the SDK. But yeah, in the meantime, unfortunately, the burden of the work is on the end user.
I see. Here we have Toastador asks, what's the difference in performance of a UDIM tile discard versus a toggleable skinned mesh? And adds that they use UDIM tile, but doesn't it technically show the mesh at all times versus actually hiding it?
Yeah, so this UDIM tiling offsets the cost onto the vertex pass of the shader. So essentially, it passes things in and tells it, hey, I want to draw these triangles. I want to draw them negative infinity far away. So most GPUs are smart enough to realize, oh, I don't actually need to draw that, and then we'll skip the fragment pass. In either case, it's mostly just a vertex cost that comes up. Because it goes completely off screen in both cases, the fragment pass, which is the pixel drawing, doesn't have to come in. So it's, like I said, it's a little bit splitting hairs nowadays. It used to be a huge difference. But avoiding the extra draw call is definitely worth it. Those are still, it puts a little bit more work on the GPU, but takes a lot off the CPU, which is the hugely constrained thing at the moment.
Let's see. We have.
Can't believe I said bigly.
Question from Cytherus. Is there any benefit to texture atlasing over multiple toggled props on worlds?
It really depends. So it's actually best to have both. You can have, I think with static batching, it manages to squish everything into one draw call where possible if it has shared materials. So with worlds, you want to use static batching as much as possible because it will only render the geometry it needs and only uses the one draw call anyway, or at least whatever the minimum number of draw calls is to cover whatever materials they have. As far as anything else, if it's like super small, super low poly, you can use instancing. Yeah, that's pretty much my advice for that.
Okay. Let me keep looking here. Does VRChat? So this is a question from Dark on the Q&A. Does VRChat plan to utilize any of the DOTS or ECS features for animators or anything else?
I believe those are the new Unity animation systems. I haven't personally looked into it, but I think obviously, at some point we have to start looking into them. We don't really know what we're going to be doing there immediately, but obviously if there's huge gains and we can move into it easily, we will definitely be looking into it.
Okay. A question here from Oski. When an avatar is not being rendered, but it is in the scene, is it still held VRAM?
Oh yeah. So unfortunately, while we don't have MIPS streaming available, every material that's loaded in the scene has all of the texture memory that it would use completely used on the GPU. So that's essentially why if you tried to jump into the 250 people instances this weekend, you had a smaller GPU, you might have crashed out. It fills up until it explodes. We hope to very soon be introducing mipmap streaming. There was some really deep technical reasons why we couldn't do it up to this point, but we think we managed to swing it now. And the hope for that is that we'll be able to dynamically manage VRAM, so just essentially any GPU will work as long as we can pass things in and out fast enough.
Very, very cool. Question from Nikki. This might have been something that was answered previously. Will there be profiling tools, something to test in Unity or in VRC, how each change affects performance?
There's a handful of tools you can use already for kind of an end user profiling. Like the OVR toolkit, as I mentioned, is great for if you have a Quest. If not, you can use MSI Afterburner. We want to have some sort of deeper profiling. I know you can break it into the Unity editor if you have the current SDK and have the world simulator enabled. That won't give you a super good overview, but it will give you an idea of where the probably problem areas of your code might end up being. But yeah, I don't think profiling realistically with the client and then getting back is something that we're still solving internally. But if we come up with a perfect solution, we will hope to release it to users.
Alrighty. Question from Okari. Regarding the shader portion, does that mean child material instances with only parameter changes don't render on the same draw cells?
I do believe it needs to be a different draw call. I would need to double check on that. I haven't toyed as much with instance materials yet, but oh no, wait, I do know this. So it's specific to the shader. The shader has to specifically implement different draw call instanced properties. And if you do, then you can make it to where it's instanced over everything in the scene and uses different things. Usually this is only for very small things, otherwise it gets very expensive. So like if you want to change the color between a bunch of different materials or something. I know this is frequently used for fonts and UI rendering. I think there's some kind of hidden costs when you try and do it with different textures and things like that.
All right, question here from Istral. For clothing toggles, is it better to use separate object toggles or blend shape scale to 0 toggles? Are there better ways to make toggles? As a second question.
Again, it's kind of splitting hairs at this point. It used to be far, far, far worse to use the blend shape thing. So the expensive blend shapes actually scales with how many vertices are being animated. If you're using a whole lot of blend shapes to do it, it's definitely worse. I would go profile it. I do know that when you combine materials, regardless, you're using less CPU time, which tends to be our more contentious area, so that's probably generally better. UDIM, the only reason I hesitate to recommend UDIM is that it's usually kind of a hard thing for users to implement, but it's something we hope to implement kind of essentially SDK side, so it does it for you one of these days.
Gotcha. Question here from Snuggly Ghost. For fizzbones, such as ears or tail fizzbones, is it better to have a central bone root and one child per ear or tail?
I think in general, from what I understand, the less Fizzbone components, the better. Internally, we have some like really complicated native processing that goes into Fizzbone, so I think they actually kind of all get poured into one area together. But I think the main reason that they get more expensive if you have more Fizzbone components is that every frame we have to go and check if all of them are still active. So in general, I think it's better to reduce the amount of Fizzbone components. That the SDK obviously pushes you in that direction. 1 or 2 extra Fizzbones is like no cost versus that.
Gotcha. I had a couple of the questions here.
Feel free to keep asking. I will keep answering them after the panel. And I apologize for my my stream setup messing up here because my overlay kept grabbing the input when I was trying to switch between the two.
Okay, no worries, no worries. So I got 2 questions here. One from Stumpy Orange Cap. Will VRChat support Magic Cloth? And then another one where Kradavir asks, will VRC support FSR or the like? I think they kind of melded together.
Yeah, Magic Cloth. I'm not actually familiar with that one. I believe that's like a third-party company that does a specific type of cloth. We've toyed internally with our own kind of cloth rendering, but obviously Fizzbones is the way to do it right now. You know, more updates if that comes out. As far as FSR, we have tried specifically to implement that because, you know, it would be a huge boost for desktop and VR users. Unfortunately, it's kind of something that's internal enough to Unity that it's very difficult to do without breaking the rendering ordering. Because it's essentially like a post-processing pass that has to happen between most of the rendering and then kind of any post effects, like any bloom or anything like that. And the main issue with it is that with, you know, if we had access to Unity internals as deeply as we do with some other things, we would be able to kind of hijack the render process and take whatever frame comes out and then pass it through the FSR before we add the bloom and everything. But because we kind of hand everything over to end users and world creators, we don't have quite that much like ability to hook into it. I think there's some plugins and things we've been investigating, and then we've also been working with our own kind of like our own Unity folks to do that. But it's still it's non-trivial, unfortunately.
Gotcha. I think we got time for at least one more question here. Question here from Dipole. Are there any plans to change the performance ranking in the near future to better represent the actual performance impact? And maybe to build on that, how has the performance ranking evolved over the life of, or at least, you know, as long as you've been here for with VRChat?
The performance ranking at the moment, it's a little antiquated. It's a, like I said, it's a good filter for the very obviously bad. It doesn't capture, I think, kind of the nuance of a lot of avatars, especially if you kind of use a bunch of one component but like are otherwise optimized between other things. We've been kind of investigating kind of a dynamic cap. Unfortunately, just the amount of profiling we have to do to make a meaningful estimate is very complicated. But it is something that we are looking into. I don't know when we can say that will be delivered, but we hope soon. It's if not, you know, we will always be looking at if we can meaningfully change the ranks to fit something more more representative of the actual frame time we expect things to take.
All right. I think we're over now. Do you have any other final comments here? I know you mentioned that you'd, if people still had questions, you'd go back into the Q&A channel and go through those, answer those if you can.
No, nothing off the top of my head. Stay furry.
All right. Thank you very much.
Thank you.